Today we're looking at Wi-Fi and wireless LAN, an essential part of setting up a communication network with devices when it comes to any home automation or data transfer. When we're dealing with a Fronius system, we're connecting our inverters via a LAN or Wi-Fi network. We're also connecting other components such as the Watt Pilot. Good communication is the key to an efficient system, so it's essential that that works as well as possible. I'm Anthony Moises, and I'll be taking you through the next half hour roughly of Wi-Fi content. And with me in the studio is my colleague, Michael, and he'll be answering any questions that you post during today's webinar. What are you likely to ask questions on? What are we going to deal with? We're going to be looking at a few specific topics. We're going to be looking at the factors that matter most when it comes to wireless LAN connections. So we'll be looking at what it is that impedes those signals and also the solutions. Simple solutions, first of all, that don't require additional hardware. Small changes you can make, small checks that you can perform to make sure you're getting the best performance and the best reach out of that system. We'll also compare a few hardware solutions that we commonly advise when it comes to improving network coverage and Wi-Fi signal within a system. Towards the end, we'll then come in and give you a short summary of all of those points so that you have a quick checklist to improve every single installation as you go through it in the future. First of all, it's important to always make sure that you determine whether or not you have sufficient signal. Now, while you could go for using complicated tools that everybody would have to have themselves, we already have the essential tools in our back pockets. And those are generally going to be mobile phones or tablets that we have on us when we go to an installation or when we go for a consultation with a customer. Whether you choose to use the simple input of your phone and check how many Wi-Fi bars you have, how strong that signal is, that is one option. As soon as you're below half signal there, that should already send alarm bells ringing. Alternatively, what you can do is you can use a few simple apps, depending on whether you're using iOS or Android, and those can be used to measure the signal strength. Make sure that you establish what signal strengths are required for whichever devices you are installing. I'm afraid to say that that is usually going to be a question of learning by experience. So based on your receiver devices, any devices you want to include into that network, you'll have to see where those levels have to be, usually in decibel. Having determined whether or not you have sufficient strength, you then know whether or not you have to act. Whether you have to act or whether you can act is going to be up to you. In some cases, we have to do something to ensure a strong data communication. But what is it that limits signal? Well, we start off generally quite close to our router or access point with a strong signal. By the time we get to our end user device, we quite often end up with a much weaker signal. Now that signal has simply lost in amplitude. But what is it that causes this? The first and foremost is generally going to be a distance between the router and the device. Free field of vision with the correct air pressure, air temperature, a good transmission of those wavelengths, even that will subside over a sufficient distance. Within a residential installation, the distance alone would normally not take too much effect. However, if we're moving into agricultural sites, if we're moving into industrial sites, we might achieve considerable ranges of over 50 meters. And at 50 meters, most standard household routers are already at their limits. Even if distance itself is not an issue, it might simply be a matter of a few meters as the crow flies, but we might be going through obstacles. Obstacles such as concrete or brick, massive walls, they're going to absorb the waves that we want to use to transmit our data. So anytime we're dealing with strong walls, we're going to have an issue. Also any form of earthworks, if we're working out of a cellar or a basement, those are going to absorb the signals quite considerably. Especially any form of concrete that contains steel or any other form of steel or metal structure, such as a container or a metal shed. These might all absorb the signals just as a Faraday cage would. So we're literally shielding our router, our access point, or our device from external signals, and that includes the Wi-Fi signal. Steel structures can also be found, for instance, in dry walling. So anytime we have an upright support system that is made up of metal structures, these can already act as a Faraday cage and can limit the amount of signal that passes through. Also in dry walling, we will often encounter wooden structures, and though wood is not metallic and it's not quite as solid or dense as concrete or brick, it is also extremely good at absorbing these wavelengths. Pretty much anytime we have an obstacle in the way, anything that is a physical barrier to us also forms a physical barrier to those wavelengths. So we're looking for, if possible, a line of sight, wide openings, but be aware of the fact that even doorways might pose a problem. If you have a metal door frame and if you are measuring your signal with the door open, but it is usually closed. Particularly garage doors, basement doors, anywhere where we have a fire compartment that is going to be closed, those areas are going to be affected by the metal doors, the gates on garages, etc. So be aware of the building material that surrounds your devices or separates them from the access point or the router. Bearing that in mind, let's try and keep it simple and look at a few simple solutions. Now, we're going to go through these three questions. What frequency are you using? Because the frequency has a considerable effect. We can also ask, can you move it? Now, we're going to be looking at either the receiver or the sender here, the access point, and also, can you turn it? And now that's going to be the router or access point in particular. First of all, the frequency. Now, when it comes to frequency, a higher frequency generally allows for a higher transfer of data, a higher data speed. Most commonly at the moment, we have 5 gigahertz as a frequency for higher speeds. Those are in excess of a gigabit per second. But the disadvantage of having a higher frequency is that it is more easily absorbed by an obstacle, such as a concrete wall. A very low amplitude will make it through these obstacles because the majority is absorbed on its way through the material. A lower frequency with a longer wavelength can pass more easily through obstacles. It can also travel a longer distance, even in line of sight. So generally using a lower frequency will get me a better signal, but at a lower data rate. That lower data rate in our respect is all right, because with the systems we're working on, we're limited to a 2.4 gigahertz ideally anyway. So using the 2.4, 2.5 gigahertz systems here, we're keeping that frequency low enough to pass through obstacles and also making sure that it is within a bandwidth that can be received by most Internet of Things devices, particularly if you're dealing with things such as an inverter. If you're dealing also with a refrigerator that is connected to the internet, you are likely to be using a lower frequency, such as the 2.4, 2.5 gigahertz networks there. The 5 gigahertz is predominantly used for end user devices such as laptops, tablets, or other browser systems, or also televisions. So selecting the correct frequency will help you here in connecting to the router, to the access point with your end device, and also overcoming those obstacles. The other option is to move it. Now, if you move it, you can either move the router, you could move the device to a certain extent, and if both are fixed, then you might be able to move the aerial that you have on either the receiver or your access point or router. Now, moving the aerial or moving the device itself simply is supposed to overcome those obstacles again. Bearing in mind that most of these devices are built into either a metal housing or a plastic housing with some metal framing, those in themselves can already be shielding your antenna, your aerials, from other signals. So by moving them slightly to the side, you might be overcoming those obstacles. If they are up against a wall in a bookshelf, for example, as is quite common, they might have rebar, reinforcing steel in the wall behind them, and by moving them just a few centimeters to the side or turning those aerials to the side, you might be bypassing that particular obstacle as well. The same thing goes for turning the devices, making sure that the aerials are towards the devices you want to connect to, as opposed to having the router or access point housing in between. Generally, they're designed in such a way that that is not an issue, but it might particularly be if the aerials are pointing up and you have your device in the way and you're trying to get down to a lower level, for example, to the inverter mounted in the basement, then you might have an issue that can be overcome by rotating that router or access point. On the topic of aerials, we can, as I said, move the aerial's position. We can also try and make sure that the connection between the aerial and the devices is a strong one. And if we have an aerial that is installed, such as here in the pilot, we can exchange some aerials. Now, by exchanging the aerials, we can increase their length, and by increasing the length of that aerial, what it gives us is a larger area to receive those few and limited signal waves that are coming through. Please be aware, if you're exchanging any aerial, that you only ever use aerials that are suited to that device. Now, that doesn't only go for the pilot, that goes for any device you're changing the aerial on. To avoid a misfunction or a permanent damage to the device, always ensure that the aerial you are installing conforms to the requirements of the device, but you can use longer aerials on most receiver devices, but also on sender devices. And by changing that, we can also extend the aerial, for example, out of the housing of our inverter. So if we were to change the aerial on our pilot, we can then lay a cable that comes out of the housing, outside anything that might mask that signal, and place this longer aerial where we have a stronger signal from our access point to the World Wide Web. Changing hardware means we are already moving into hardware solutions. So these are now things that are not as easy to manipulate, but things that you can already have with you when you go to the installation to be prepared. By this, we're extending networks. We're adding something to the existing network at the customer site, and that can either be adding another network, or we can be piggybacking onto their network and adding hardware to improve the signal. The first of these options is going to be repeaters. Now, repeaters basically work a little bit like Chinese whispers or a bucket chain. They're going to be placed where they are still in range of the existing network, where they can establish contact to the router, to the access point that is nearest them that they're connected to. And at the same time, they're acting as a middleman and communicating to the device that would otherwise be out of range. They're a very simple solution. However, they do act, as I said, like a bucket chain. They can only hand things on once they have them. And what that means is that they do slow the process down. They're obviously only able to pass things on as fast as they get them, and the older generations particularly had only a receive or send, a little bit like a walkie-talkie, that you could either press the button to talk or you could be listening. Newer versions do sometimes overcome that obstacle as well, but be aware of the fact it will slow down the communication. They also have the disadvantage of sometimes having their own SSID. So that is the identification of the network, the name the network has. And if you have devices that have to be within the same SSID to exchange data, then a repeater might not be the correct solution, or that particular repeater might not be the solution that you need. A repeater also always communicates to a fixed point, so you always dedicate an access point or another repeater for it to communicate with. Now that means it can also be rerouting a lot of data via one channel that's already blocked. As we said, they can receive and send, but they're limited in how much they can send at the same time. And if you have a lot of data traffic traveling via one repeater, that's going to be a bottleneck. If you had an option, then you might be able to diverge to a normally slower network that in this case would be the faster option. But the repeater doesn't offer you that option because of the direct connection it has, giving it an indirect route to your access point. Furthermore, be aware of the fact that repeaters exist in these different frequencies as well. So they might be in a low frequency or in the 5 gigahertz or even 6 gigahertz by now for a Wi-Fi 6 system. So be aware of the fact that even if your access point would be in the correct frequency, that frequency might be changed by the repeater. As an alternative to repeaters, there is also the possibility of mesh. Now, mesh does a very similar job of repeating systems, but they can also be connected via a LAN cable, and then those mesh devices, those access points, actually can connect independently. That means they can redirect traffic to the fastest route to the internet or to your local access point. These are much more efficient. They also have a common SSID, so anything that is within this mesh-formed network will access the same network name and can therefore exchange information within the network more easily, unlike that new SSID that the repeaters sometimes develop. The other benefit of a mesh system is that it can operate on multiple bandwidths and multiple frequencies. In other words, the mesh devices amongst each other might be connected via Wi-Fi at, say, a 5 gigahertz network, and they might have a data communication then to Internet of Things, the 2.4, and they might then also have a second network that they set up at 5 gigahertz for you to browse with. By splitting up the different users, the different communication lines to those different frequencies, it means that they can work simultaneously to serve multiple purposes and also hand that data on to the next station in line. A mesh system can be expensive to install by comparison, and above all, it involves getting into a customer's network systems, changing things. If you're already installing a new system, then a mesh is certainly something you should be considering. But if you're using existing infrastructure and you're just trying to get that little bit of extra range, the mesh itself might be overkill. Instead, you might go down a different line and go for a Powerline adapter. A Powerline adapter is a way of transferring data via a hardline connection that's already in the walls, namely the power line from one socket to another. What the Powerline adapter does is you connect the sender, via a LAN cable usually to your access point or router, and that then transfers a signal to the power line, and it uses the frequency of the electricity to transfer that to other sockets. Then you have a receiver that is plugged in at the other end, and that then transmits a Wi-Fi signal to the household. It has effectively a hardline connection through obstacles such as walls, where you already have those power lines in, so it is a very useful tool to overcome those. It also already uses the infrastructure, so you're not pulling in additional cables. If you don't have space in a conduit, for example, then that doesn't matter particularly. They can also transfer data from one phase to another by induction, so they're transferring over a parallel stretch where those wires run together, but they are also susceptible to high frequencies or harmonics. So if you have a lot of devices in a system that are already creating harmonics, those harmonics might foul up the system that the Powerline adapters use, because effectively they are using controlled harmonics. Having decided which of these solutions you want to use, or even if you are approaching an existing infrastructure and you might have to make small adaptations, it is worth considering the management of the network. Should you be using a router at every turn? Should every connection where you basically only need a switch, so a multi-plug to connect several LAN cables and maybe then also adding in some form of Wi-Fi system, should you be using an extra router there as well? Well, let's look at a few small criteria just to help you along with the decision making. If you're trying to make up your mind whether to use an access point or a router, it is quite important to bear in mind this management schematic. A router usually combines the modem and is at the main distribution point, let's say, of that network. If you have other routers further down, each one needs its own management. You can set the firewalls in it, you can alter the IP address or the way that those are designated, but all of those need managing individually. So if you change something in the system, you're going through all of those devices and changing each one individually. The alternative would be to use an access point. Now, all an access point does is it takes that signal from a LAN cable, for example, and turns it into a wireless system. It transmits it into waves. That access point will take on any settings that it gets from the connected router. So for a larger management system, you're probably going to be heading down this route rather than individual routers at every turn. It simply makes it easier to manage centrally for each individual change. That was the key information. Let's go through it once more so that you have a quick checklist of what it is that you can check first when you get to an installation or when you're considering improving the Wi-Fi signal somewhere. First of all, have we tested the signal strength? Do we even have a Wi-Fi signal there? Do we have a Wi-Fi signal that isn't quite strong enough? And where do we have a signal that is? As of which point can we duplicate that signal or hand it on? The tools you should use there are any that you have to hand, and the easiest there is going to be your mobile device with suitable apps on it. Are you using the correct network? Now, this network could relate to either the SSID. Are you within the same network? For example, you're using the Watt pilot, you want to communicate with an inverter, you should be using the same SSID there to keep them in communication. But also, are you in the correct frequency? We said we want to keep down to those 2.4 gigahertz if we're using an Internet of Things network, so any devices that are serving in that sector. Then also, where is our access point or our router? Where is it located? Is it perhaps shielded by something? Is it stuck into a corner of a room with reinforced concrete walls? And can we reposition it? Can we move it away from that concrete? Can we move it away from the steel? Can we change the level that it's at to maybe get past a layer of steel or better pass the signal through a reinforced ceiling? Or can we reposition the aerial, either of the access point or also in the device that we want to connect, either by rotating it, by swinging it outwards, that it is more exposed within the housing, or also by replacing it with a longer aerial. Another alternative, can we use a Powerline adapter? As a Powerline adapter is the easiest thing to implement. It's a plug and play solution in most installations. That should probably be our first go-to. Do we have a power line that goes through? And can we get a connection using a power line adapter, or do we have too many harmonics in the line? Or maybe even the problem that we don't have a sufficient connection between those two sockets. As an alternative then, is there mesh available? Is mesh an option? Should we be installing mesh, or is it already in place? And is the cost worth it? And if those are not an option, then we can always still use the trusty repeater. A little bit fiddly to get working sometimes, but if it works as a plug and play option, then it is one of the simplest go-tos, at least for the initial setup. Anytime you have problems with Wi-Fi, with connectivity, or also with other steps in the process, then please do look at our YouTube channel for other how-to videos, for example, or also webinars on similar topics and anything that is related. The recording of today's webinar is going to be broadcast to you. You're going to get a link to it in the very near future. If you are interested in further webinars, then please look us up on the website fronius.com. Alternatively, feel free to visit us for face-to-face trainings or here again in the studio for online trainings. We'll still answer any questions that there are in the chat. So if you asked a question, feel free to stay online for a few more minutes until we get back to you. Everybody gets an answer, I promise. In the meantime, from me in the studio, and until next time, I wish you a wonderful day still, and goodbye.